In Chapter 1, we introduced you to research validity, which addressed internal and external validity. We've now switched over to measurement validity. We talked about that in a previous video. Measurement validity is important. Whenever you assess something, you want to do that validly. This figure illustrates measurement validity. On the left-hand side, we have relevance, face and content validity, which are subjective in nature. On the right-hand side, we have empirical validity. Empirical validity typically results in numbers. We have criterion validity, which can be further broken down into concurrent and predictive validity. And then we have research-related or experimentally based validity, which consists of construct, convergent, and discriminant validity. Let's talk briefly about each of these.
Relevance validity consists of face validity and content validity. These are subjectively assessed. Face validity is basically an observation of whether the measurement process on the face of it looks like it is measuring the trait that you are trying to assess. Content validity is a little more detailed and involves critical analysis of the assessment process, the measurement process. For example, if you look at a written examination and decide that it is measuring knowledge of physiology, you need to look more critically and determine if it totally covers the topic that was taught to see if the test would measure accurately people's knowledge of that particular section or that particular unit.
Under criterion validity, we need to have a criterion. Perhaps the best example is skin fold measures. The criterion measure for determining body composition characteristics would be hydrostatically determined body composition, or DEXA. And in fact, you can take skin fold measures because skin fold measures correlate very highly with hydrostatically determined body composition characteristics. That's to say, at the same time, concurrently, there's a correlation between the criterion measure, DEXA, and skin fold measures. Alternatively, you could have predictive validity. How well does one measure taken at this point in time predict something in the future? Again, we have a criterion. The criterion might be alive or dead. How well does what you do today with regard to diet, nutrition, physical activity predict what your status will be in the future? That's predictive validity. Essentially, the real difference between concurrent and predictive validity is when you measure the criterion. With concurrent validity, you're looking for the correlation concurrently at the same time. With predictive validity, you're measuring the criterion sometime in the future.
Construct validity, we're talking about under the category of empirical validity, but we're over on the right-hand side where we're looking at research-related validity, and the first type of validity under this is called construct validity. Not everything that we measure is tangible. There are things that you can't hold in your hand, for example, intelligence, creativity, self-concept. How do we construct measurements to assess these constructs, and how do we show that we are actually measuring these constructs? This is typically done through experimentation. Construct validity is generally assessed through some type of an experiment. For example, is there such a thing as attitude toward physical activity? To build an instrument that would measure this and check its validity, we would build our instrument and then administer that instrument to people who engage in various amounts of physical activity. The assumption would be that if the measuring instrument is valid, those people who participate in more physical activity would score higher on the instrument than people who are not.
Convergent and discriminant validity relate to correlational validity in the sense that you're looking at whether or not there's a relationship between variables. Take, for example, balance. Assume that you believe that there are two types of balance. Dynamic balance, which is balance when you're moving, and static balance, which is balance when you are standing still. If you administered 5 measures of dynamic balance and 5 measures of static balance, if dynamic and static balance truly do exist, the items that measure dynamic balance would all tend to correlate fairly moderately or highly. The 5 items that measure static balance would tend to correlate moderately or highly. But yet when you looked at the correlations between items that are dynamic and static balance, if in fact dynamic balance is different than static balance, then those correlations would be low. So, within dynamic balance, they tend to converge. They correlate highly. Within static balance, they tend to converge. They correlate highly. But across dynamic and static balance, they correlate very low, so they discriminate amongst those kinds of variables where you think that they have different constructs underlying them.
Measurement validity is very, very important to statistics, because if you are going to use a statistical test to determine differences or correlations, if your measurements are not valid to begin with, then applying the statistical tests really amount to nothing. We have tried to show here there are many ways to determine validity. Not all of them can be used in every situation. Sometimes it's only possible to talk about subjectively content and face validity. Sometimes variables are not easy to measure, and determining validity is a difficult process.
Importantly, if you're using a new instrument for your experiment or your research, you need to validate that instrument. It's a new measure. How do you know that it truthfully measures what you report that it measures?
And if you are using a measurement that has been used in the past, it's important for you to be able to demonstrate why that measurement is acceptable in your study and what its validity is.